In the last video, we learned some basic thing about CMake. Today, we are going to build our GDExtension project using CMake. Here, I have a brand new Godot project. To keep things organized, I'll create my GDExtension C++ code inside the project itself. So I'll make a new folder called cpp. Inside this folder, I'll create an empty file named .gdignore. What this file does is simple. It tells Godot to ignore this folder, so Godot won't try to load anything from it. We'll put all of our C++ code here and build a shade library from it. Godot only needs to see that shade library, not the source code itself. Next, I'll create a .gitignore file since we are going to use Git to manage our project. This file helps us ignore certain files and folders. Inside it, I'll add build directory to ignore list. We'll use the build directory to build our project with CMake and make. If you use other directory for building, make sure to ignore those as well. Okay, after that, inside my cpp directory, I just run git init command to start my Git project. Next, we need to add godot-cpp to our project. Open the godot-cpp repository page and copy its Git URL. Here, I want to add godot-cpp as a submodule in this project. Adding a submodule had a few advantages. It keeps the dependency separate from your main code, make it easier to update to new version, and also take up less space on GitHub. So just type git submodule, add, and then your repo URL and the path of the submodule. As you can see, this command add godot-cpp as a submodule on their external directory. Okay, after that, go inside godot-cpp folder and switch the correct branch that match your Godot version. Here, I switched that to the Godot 4.5. Now let's make our CMake list.txt file. Inside it, I set the minimum version, and for project name, I set it to gdhello. And just here, need to add godot-cpp as a subdirectory. After doing that, I run CMake and make. You can see the debug version of the godot-cpp static library is added inside bin directory. Now what if we want to build the release version? For that, we need to set some variable when running CMake. If you run CMake with -l option, you can see a list of available options that you can modify. In this case, I want to change the godot-cpp target variable from template debug to template release. To change any CMake variable from the command line, just add -d followed by the variable name and equal sign and then the value. So here I'll set godot-cpp target to template release. Now there is more easy way to modify CMake option, and that is using CMake GUI. Usually CMake GUI will be installed when you install CMake. So here in build folder, I just run CMake GUI with dot, which dot tells CMake GUI to open the current folder. You can modify any CMake option here and click on the configure and generate. If I run make again, you'll see the release version of godot-cpp get built. You can change other build option too. For example, you can change the precision to double. Alright, let's see how we can add our own code to this GDExtension project. I'll start by creating a new directory called src. Before adding any custom Godot classes written in C++ inside this folder, we first need to define an entry point for our GDExtension library. The entry point is a function that runs right after Godot load our GDExtension library. Inside that function, we register our custom Godot classes and their methods so Godot can recognize and use them. In the godot-cpp repository, there is a test directory that contains an example register file. We can use that as reference for setting our own entry point. So I copy and paste those register header and cpp file into my src folder. So in the register cpp file, you can see this is our entry point function. Inside this function, we pass two function pointer. The first one is initializer function pointer. This one is used to register our class after loading our GDExtension library. And the second one is called before our GDExtension library get unloaded. We can also specify at which level the GDExtension should be initialized. The current setup uses the scene level and I keep it that way. So in the terminator function, we don't need to do much, but in the initializer function, we need to register our own classes. As you can see, the test classes are already registered here, but I remove the test header and code. Later, I will add my own classes here. Now our code contains an entry point, but it doesn't include any custom Godot classes yet. Even at this stage, we can already build our GDExtension library. To do that, we need to compile this registered CPP file, link it with the godot-cpp static library, and build a shared library from that. Later, when we add more C++ file, we'll also need to compile those and include them in the build. Once that's done, Godot will load the shared library, call the entry point function, and register all our custom Godot classes. So for now, let's build our shared library. Later, I will add some custom classes here. In our CMake file, we need to get all CPP file inside the source folder. I'll use file function to do that. I explained about this function in the last video, so if you don't understand this, please watch the last video. Now here my src will contain all .cpp file inside source directory. After that, I create a shell library using this .cpp file. Then I link the GDHello with go.cpp static library. Remember, the go.cpp target was already added earlier when we include go.cpp as subdirectory in our project. Now I run CMake and make again. And as you can see, our GDHello shared library is created inside the build directory. One thing to note is that the name of this library doesn't give us much information about it. If you look at the godot-cpp static library, you'll notice its name includes useful detail like the operating system, whether it is a debug or release build, and the CPU architecture. You could write a custom function to generate a name like that, but inside the godot-cpp CMake setup, this formatted name is already provided for us. If you look at CMake list.txt file inside godot-cpp folder, you will see that the main godot-cpp static library is not defined directly here. Instead, it's added inside a separate CMake include file, which is included from the main CMake list. Inside this CMake include file, you can see where the library itself is added, and a bit further down, some property for the godot-cpp target are also set. In this section, there is a useful comment that explains here there are several handy custom property for godot-cpp that we can use in our own project. One of them is godot-cpp suffix, which I'm going to use. So in my CMake file, I use get target property to retrieve that custom property. This basically gets the godot-cpp suffix and store it in a variable called name suffix. Now that we have our name suffix, let's change the name of our library. You could change it by modifying the target name in add library function, but it is usually better to keep the target name simple. Instead, we use the set target property function to change the name of the library. The property that we need to set is output name, and I set it to GDHello followed by the name suffix. And if I run CMake and make again, you can see our library has a proper name. Another thing that I want to do is to change the location of the build library. I want to move my shell library into the main project folder since the CPP directory is invisible to Godot. To do this, we set the library output directory property. I set it to the lib folder in the parent directory of the current CMake file. Okay, now if I run CMake and make again, you can see our library is built inside lib directory. Now that we have our GDExtension library inside the Godot project, we need to tell Godot how to use it. For that, we create a text file, which is named end with .gdextension. I copied the example text file from the godot-cpp test project. Okay, now inside this file, we have a bunch of feature tags and the library path for each particular feature tags. If you are not familiar with their feature tags in Godot, I recommend checking out the Godot documentation. Basically, feature tag describe things like platform, Windows, Linux, etc., the CPU architecture, and whether it is a debug or release build. You can even add custom feature tag if you want. In our example, we specify if the feature tag Linux, debug, and x86-64 exist, use this lib. So I specify my lib path for debug and release on Linux. You may change this depending on your platform. And here at the top, the entry point should match the function entry point in the register.cpp file. I also update the minimum compatibility version to 4.5. Now let's run Godot. Okay, if you see error like this, it means something is wrong. This issue here is that the Godot editor needs the debug version of the GDExtension library. But right now in the lib folder, we only have the release version. So I quickly built the debug version to fix that. Okay, as you can see, we no longer have any error and our GDExtension library is loaded successfully. But right now our GDExtension doesn't have any custom classes. Let's add one. In the src directory, I create a gdhello header file. Here I include the node class header file and I use the Godot namespace. After that, I create a gdhello class that inherits from the node class. Now, every time we create a custom Godot class, we normally need to define several functions. For example, we need to add a static function called getClassStatic, which returns the string class name, or we should override the isExtension class function to always return true. We also need to handle other things like notification binding. The good news is that there is a macro that does all of these things for you. You just add gd class followed by the name of the class and the name of the class which it inherits from. Inside this macro, all these functions are automatically will be defined for you. After that, I create a static function which return void, which is called bind methods. In this function, we'll bind any method that we want to call from GDExscript. For now, I just create the function and I'll explain method binding in more detail in another video. I right click on this function and I create its body. Okay, now we have also .cpp file for this class. Now we need to register our class. Inside the register.cpp file, include the header file for your class. Then in the initializer function, register it using gdregister class macro. Another useful step is to add the src directory to the include path. Now I recompile the program. And you'll see the GDHello class node is available in Godot. Now there is one more step for our project setup. I'm using VS Code as my editor, which has some great feature for C++. It can detect error and autocomplete include path. This works best when VS Code sees exactly what compiler sees. You could manually add include directory in VS Code, but there is a better way to do this automatically. We can use CMake to export the compiler command. To do this, open the build directory with CMake GUI and enable advanced option. Then search for CMake export compile command and activate that. After running CMake again, you should see a compile command.json file inside the build folder. Now inside VS Code, if you have any C++ file open, you'll see a button usually showing your operating system name in the bottom right corner. Click on that, then choose Configure UI. Here I remove the existing include path since we are going to use compile commands. Scroll down, select Advanced, and add the path of your compile command here. This way VS Code will see exactly what the compiler sees. And that was it about this video. I hope this video helped you. If you have any question, leave it at comment below. Have a good time. Goodbye.